Before you put SpeedScale in your production environment, one of the things you're going to want to do is configure the data loss prevention, or DLP. You can identify the data that you don't want to be captured so you can get the structure of your API calls and database calls without the sensitive fields involved. We're going to go through the data in this guide. We're going to go through it live inside the product here. So I'm going to switch over to one of my non-prod environments because I want to see how the application currently runs so that I can demonstrate where the sensitive fields are coming from. Okay, so I've got a little bit of traffic from this Java auth service. This is just an open source demo app that we have on our GitHub repo. And I'm going to go ahead and start by just saving it into a snapshot because I'm going to use the snapshot configuration screen to identify where the sensitive data is and make sure that I can see that it's properly redacted. So I'm already familiar with this application and I can jump right into a couple of the fields that I want to work with. So one is this access token. These tokens are used to log into the application. So even though they're short-lived, I still don't want them to be sent. So it's as easy as hitting the pencil icon here, coming to the data privacy section and saying, I want to redact that field. Now we're selecting redacting the field because we're not going to redact the entire payload there, but just the one field that we care about. So we're going to go ahead and save that, and that will make a new transform rule that we can see here. And you can kind of read this from left to right. Go to the login endpoint, go to the response body, so what we get back from the application, and redact that access token. And now when we open it up, we can see very clearly that that data has been redacted. So, and kind of pay attention to this format because we're going to see this a couple of times. Now in this case, I also happen to have, because this is a user login, I have the username and password. So you've got other options on what you can do with this, by the way. So one is you can just scrub it, blank it out all through the data. Or if you want to be really granular, you can use the redact. I'm going to use the redact in this example. So now I've got two rules that both apply to that login endpoint. But I know that the data also shows up in these other requests in the header. There's an authorization header where that token is used. This is that same token we were just looking at. In case you're ever curious what's inside, there's an auth tab that will kind of break it open for you so you can see things like what's the subject, when was it issued, and when will this token expire. But in our case, we want to redact this field. So we're going to come in and say redact it. It's kind of boring, same setting that you're doing here, but now I can see that that rule is being applied and transforms are showing up, and this is great. Now one thing here is if you go back to the header, you can see this header is a little bit different. It has a word in front of the token, and so this came back and said unrecognized. So what you can do is actually use a little chain to keep this word that we want, but redact the token behind it. So we've got kind of an advanced view here where I can add another transform, and we have a transform called split. So I'm just going to search for it, split. So we're going to split this string. We want to keep the first one, but redact the second one. These are indexed by 0. So index 1 is what's going to get redacted. And now I can see these are out of order. I need to do the split first and then do the redact. So now when I save that, after it's done processing, I'll be able to go in and take a look at the request headers, and I can see this is what I want to see. The word bearer is still kept, and then the JWT has been redacted. It's not limited just to HTTP calls. I've also got some database interactions here, and let me see if I can find one of these examples. This should be a request. Let me check this here. So this is getting the user, email, password, all that information. I can come in here to the response, identify where that password is being returned, and I can see this password is just showing up in clear text here. I want to get rid of that, so I am going to redact that. Again, we keep using the redact field because we're being really granular and specific and redacting individual field elements. So what I've ended up doing here is I have one rule on the database side, and I've got 3 or 4 rules here that are happening on the inbound side. So now I've got my collection that I want to use as my data loss prevention setup. So I can just come in and save this as a DLP rule. I will call this DLP example, and that creates a new rule that I can find here on the left hand side. In the DLP rule section, I should have my DLP example, and you can see this has just made it easy for me so that I know everything is working and I visually saw it, so I know that these are the values that I need to redact. So my setup is ready. Now I just need to change my cluster so that my cluster picks up these new settings. So over in the infrastructure section, I've got one of my test clusters I'm using, this Kalima cluster, and on the configuration screen here you can see the defaults that are used. So the DLP setting is currently set to standard and the with DLP is unchecked. So we're going to change both of these to our DLP example and we're going to check it. So you see on the right hand side these new values were put in. These are our overrides. So the override is updating, overriding, or changing the out-of-the-box settings. Your other option for this is actually to go to the Helm chart when you install it, and you can put this in your infrastructure as code. So you would put change that enabled flag to true to say you want to redact the data, and then change the configuration as well. Either way, they work in a similar way. This is a little more locked down. This is what I would recommend when you get into your production environment. Okay, I waited a couple of minutes for things to restart, and now I've got some traffic flowing in. Let me take a look and see if my data loss prevention rules are working the way that I expect. So I can come in here and see this. This is the get call. It has auth header, and boom, I can see the auth header is redacted. Now I know sensitive data is not being sent up to SpeedScale. My rules are working the way that I want. Let me go ahead and save this off into a new snapshot. Now you're probably saying, well, now that the redacted data is in there, how can we use this? How can we make this work? So you've got 2 options here. One option is you can come in and still set up transforms the same way you normally do. You come in here and say, these 2 are not authenticated. We don't need to worry about those, but this login one, let's go grab this. And even though we don't know the real value of these, we can still use transforms on them. Store this in a variable called token, save that off. So we have, this is a normal transform setup you'll use for OAuth handshakes and things like that. Come in here to this and replace this with our new runtime value bearer, and then substitute the runtime token in there. This will work even though the data, the real values don't ever get sent up to SpeedScale Cloud. They'll, at runtime, it runs inside your cluster and it will always use the live values. I forgot one other change was that password also got redacted. So let me go ahead and put in the normal password. Now in my case, I only have one database set up, but if I had one for production with one set of passwords and one for staging for different passwords, I could replace them like this. Now you may be saying, hey, if I've got lots of users running in the environment, I may not want to go and set up all these transforms. So that's one option, is to use these transforms. And when this is done processing, I will show you the second option that we have. This is a quick and dirty way that will work if you have a small amount of traffic, but if you have a really large amount of traffic with lots of users, you might need something a little bit more sophisticated. So you come in here, your other option is to extract the DLP tokens. This helps you figure out what values have to be replaced. This will make a little data set. It goes into the user data section, and then you can download this CSV, populate it with new values, and then hook it up to your snapshot. So this is also covered in the documentation, In my case, I only really working with one user, so I don't have to do that. So let me go ahead and take this snapshot that I just updated, and I'm going to go ahead and replay this in my test environment. So I've already got everything running. Just for simplicity, I'm not going to do anything with the service mocks here. I'm just going to replay the inbound traffic. Let me make sure I am replaying it in the right namespace. Okay, so it'll replay the Java Auth service traffic into the Java Auth service Kubernetes service. So this report will take about a minute or two to complete. So I'm going to pause the video and we'll come back in a second. Okay, now that the report is done, we can see at a glance, there's not a lot of data in the performance section. It only ran for a couple of seconds. But if we go into the accuracy section, we can see how things work. So all of the calls were successful and all of the assertions are successful. You may notice actually there's a 500 error in here. I'm just going to pull this open real quick. If you check the assertions, that's what was recorded. So we recorded a 500. When we replayed it, it worked the same way. So the part I really want to look at though is the login call. So I'm going to just expand this a little bit to make it easier to see. So we can see the access token that was originally recorded was this one. It ends in 76. At replay time, some new one is used. And again, we don't know what the value is because we still have our data loss prevention turned on. And then when we go to the user endpoint and we check the request headers, we can see the same thing. So it was recorded the 76, but at replay time, our new value was worked. Anyway, we are good to go because all of the assertions are passing and all of the communication is still working and none of the sensitive data has left your environment. So in this video, we covered how to set up the data loss prevention, how to configure it in your cluster, set up transformations to change the values, and then run it and see what the results look like. So if you want to check this out for yourself, this demo app is available on GitHub. And if you've got any questions, please feel free to reach out to us on our Slack community. Thank you.